Hello everyone, today we're going to be talking about the terminal velocity part 2. This is the formula that we are going to be working with today. As you can see, in this formula, the buoyancy is being neglected. So this formula should only be used when you are certain that the buoyancy effect is not too great. Here only the density of the medium is being taken into account. Let's look at all these elements step by step. First of all, we have the big W. The big W stands for the weight, which is the acceleration times the mass of our object. Then, the rho represents the density of the gas, or the medium. Third, there is the cross-sectional area. Basically, it is the area that is being shown to the direction in which the object is falling. For example, if you have a ball fly in your direction, all you see is this 2D model of a shape because of your perspective. Or if you see a skydiver, for example, above you, you only see the front of his body and the 2D shape of a person. You don't see his back and you don't take it into account. You can think of the cross-sectional area as the area that ultimately provides air resistance. For example, the parachute adds additional cross-sectional area, which then slows the person that is using it down. And last but not least, there's the drag coefficient. As I've already said in part 1, there will be a separate video addressing the drag coefficient because it's a topic that would, in my opinion, require another video. And without further ado, let's get started. So as the first element, we have the 2W. Here we'll have to take the ball weight, which in our case is 1 kilogram, times the gravitational acceleration, which is 9.81 meters per second squared, and double all of that. As you see down here, this would result in 18.62 Newton. Newton being a unit of force. Then we are assuming that our object is falling through air, and the air's density is already given with 1.225 kilograms per cubic meter. If you don't know how to calculate the density, I've already published a video addressing that. The big A represents the cross-sectional area. Given is that the ball radius is 0.05 meters or 5 centimeters. Here we just calculate the 2D area of the cross-sectional area. Because, as I said, what you see and what the ground sees if the ball is flying towards it is only the 2D shape of the ball, regardless of its three-dimensionality. So we take 0.05 meters as a radius, square it, and multiply it with pi, and we get 0.00785 square meters. And last but not least, the drag coefficient is 0.5 because we're talking about a sphere that is falling. Once you insert all these values into the formula, you should be getting a value of around 62 or 63 meters per second as a result, as the terminal velocity that we just calculated. If you have any questions, drop them in the comments. I hope you learned something. Have a great day. And that's it for the video. If you like the channel and want to see more every Saturday, then feel free to subscribe. You can always change your mind, and it's totally free.